Howdy. I wanted to go over today's quiz so that you had an opportunity to see what your work should look like. A lot of you came up with very nice graphs, and the meat of your analysis was pretty sound. I want to focus a lot on the way that you communicate your analysis, because certain things are necessary to have and certain things should not be present. And I wanted to make sure that everybody is clear and on the same page with that. So in our quiz today, we had f of x equals 2x squared minus 8 over x squared plus 3x minus 10. And the first question asks us to find the excluded values. What I'm going to do is to write the things that were necessary for you to have in red. The excluded values are the values that cannot be substituted in for x because they would lead to division by 0. And so to find the excluded values, I must set the denominator equal to 0 and then solve in whatever way seems suitable. In this case, factoring is our friend. And so we get the solution here, x equals -5 and x equals 2. The second line was not absolutely necessary to write, although it was very helpful to write. But the things in red there right here were each worth 1 point. And the reason it was necessary to write that my denominator is equal to 0 is that this shows the logic here that we are excluding values because they would cause division by 0, and this now gives us an equation that we can solve for x. I had a large number of students who wrote something like this, and this only got 1 point out of 2, because it does not show that we are actually trying to find out what values of x make this thing be 0. So, if we want our polynomial to be equal to 0, then we have to actually say that. And you could either say that the polynomial equals 0 like this, or you could say that the factored polynomial equals 0 like that. Either one of these would get you the point. Now that I've found these excluded values, I needed to classify each as a vertical asymptote or a whole. And the only way that we have to classify these is with a limit. So I'm going to take each one of these excluded values in turn, and I'm going to consider the limit as x goes to each one in turn. Now here is where close attention needs to be paid, because many of you are struggling with the way in which you evaluate and write these limits. Okay. I can write either one of these right here as my limit. And now, before I do anything else, I need to check the form. And when I check the form, lo and behold, my limit turns out to have a value of, my form turns out to have a value of, let's see, that's going to be 50 minus 8 is 42. And in the denominator right here, lo and behold, I get 0. This is not the actual limit. This is simply its form. And so the form needs to be off to the side right here. I had a large number of students try to tell me that the limit itself equals 42 over 0. No, no, and definitely no. Division by 0 does not give us a number, and I cannot ever say something is equal to 42 over 0. If you find yourself writing equal something over 0, find a different way to say that. Instead of saying that, we're going to put our form over here. And this form tells us that my limit is infinite. It's going to give me either plus infinity or minus infinity. And it also tells me that I have to be careful to distinguish between left and right. So as soon as I see that infinite form, I know that I must split my limit into limit from the left, excuse me, the limit from the right and the limit from the left. I know that all of this requires some patience on your part, but you have to do it. And you have to pretty much write it like this. There is no other way to write it. So I have a large number of students try to write this in some other way. This is the only way. Now, to evaluate these limits, we're going to consider some sign analysis. And the sign analysis, likewise, is off to the side over here. For the top, when x is close to -5 from either side, then the top is going to be close to 42. And so that's a positive number in the top. For the denominator, maybe we want to write this in factor form. -5 on the right. X squared minus 8. And I'm going to write just the factor form at the bottom, x plus 5, x minus 2. In the denominator here, as x goes to -5 from the right, then -5, a number that is a little bit larger than -5, maybe -4.9, plus 5 is going to give me a positive residue. The sign here will be positive, and the sign here, -5 minus 2, will be negative, so that my sign analysis gives me a positive value on the top and a negative value on the bottom. And that indicates that my limit is going to be negative infinity. Let me put my sign, I'm out of room here. So let me put my sign analysis above. Okay. And then in the bottom, for x's that are close to -5, but a little bit less than -5, say -5.1. Then when I add 5 to those, I'm going to get a small negative residue times -7, which is going to give me a positive value, just like that. And the result is that my limit is going to go to positive infinity. This was the hardest analysis on the entire quiz because we had to be careful about it. And honestly, it was a lot easier to do the analysis starting with 2. The only reason I did -5 first was because I wrote it first here, but I prefer to find my holes first if I can. So how do I conclude all of this? Well, my analysis gives me an infinite limit, and an infinite limit indicates a vertical asymptote. I want to emphasize again that a vertical asymptote is a line, and therefore it has an equation x equals something, a vertical line. In this case, x equals -5. Now we're ready to analyze x equals 2. And so we're going to take the limit as x goes to 2 of f of x, which I'll just write as what it is, which is 2x squared minus 8 over x squared plus 3x minus 10. Please note that when I check the form on this one, the form that I get is very different from the previous one. I get 0 over 0, which is an indeterminate form. Now here I have to jump up and down and fuss a little bit because a number of you saw the 0 over 0 and concluded, therefore hold. And that's wrong. There are graphs, and I can show you one pretty easily, that have a form of 0 over 0, a particular limit, that actually end up with a vertical asymptote. So you may not reason from indeterminate form, therefore hold, even though that is a common occurrence. Instead, we have to reason correctly. If I see an indeterminate form, that tells me common factor. And so I go and I find that common factor. And lo and behold, the top factor is x minus 2 times x minus 2 times x plus 2. And of course, the bottom we've already factored, like so. And the common factor of x minus 2 cancels out. And now I can let x go to 2, and I get the value of 8 over 7. It is this value right here, the fact that I got a finite value, that indicates that there is a hold at the point 2, 8 sevenths. So we want to be very clear on our logic. The form does not say hold. The form here says common factor. The value right here says hold. Well, that was our analysis. This was actually worth a total of 7 points. Let me tell you what I was looking for. I was again looking to see that you found the excluded values by setting the denominator equal to 0, and that you correctly solved giving -5 and 2 for those values. Then I gave you 1 point simply for taking limits, right there. Let me put that in a different color. I gave you 1 point for taking limits, right here. And I gave you 1 point for correctly identifying that we had a vertical asymptote here, and 1 point for correctly identifying that we had a hold right there. And I gave 1 point for getting the correct limits here, and the correct limits of negative infinity, positive infinity there. And I believe, yep, that adds up to 7 total points. Well, the other questions were easier. Find the zeros of f of x. Now that we have dealt with our excluded values, I find it most convenient to use the reduced fraction for f of x, as long as we understand that x cannot be equal to the excluded value of 2. And the reason I find it most convenient is that it allows me to avoid a mistake that several of you made. The zeros are going to occur when my numerator is equal to 0. So I gave 1 point for setting the numerator equal to 0, either in the original or in the reduced fraction. But now, in the original here, when I solve, then I get the 1, 0 for the function, which was x equals -2. If I use the entire numerator from the original function, then I get 2 solutions to the equation, but one of these solutions is a false solution. X equals 2 cannot be a 0 because it is already an excluded value. So, using the reduced fraction helped me avoid the temptation to find the false or spurious solution right here. So we got 1 point for having numerator equal to 0, and 1 point for having the single correct 0, x equals -2. Finally, to find the horizontal asymptotes, I must take limits as x goes to infinity, and also as x goes to -infinity. Several of you only took the limit as x goes to infinity, and this is incomplete. and I must begin by taking the limit as x goes to infinity of the actual function itself, or the reduced fraction, either way. And whichever way I do it, now it is time for the end model and the conclusion. And because I happen to know that I'm dealing with a rational function, and rational functions always have same limits from left and right, then I can cut to the chase and just say that this is equal to 2. This gets you a point, finding the limits at infinity and negative infinity. But now I have to draw a conclusion. And the conclusion I have to draw is that y equals 2 is the horizontal asymptote. This conclusion, separate from the limits at infinity, was a separate form. I had a number of students who were so happy to get their limit of 2 right here that they just quit without actually answering the question. The question was not what's the limit at infinity, the question was what is the horizontal asymptote. And I did have a few students who still tried to tell me that the horizontal asymptote was 2. And that is wrong. 2 is a number. Y equals 2 is a horizontal line. Well, finally, we're ready to sketch the graph. So let's get some graph paper here. And I'm just going to collect all the information that we previously had about f. We found that it had a hole at 2,8/7. We found that it had a vertical asymptote, x equals -5. We found that it had a horizontal asymptote, y equals 2, and it had a 0, x equals -2. So let's put all of that information onto our graph. Here comes the horizontal asymptote, y equals 2. The arrowhead is just extra. We don't need to worry about that. And here comes our vertical asymptote, x equals -5. And we are going to plot our 0 at x equals -2. And we're also going to plot our hole at x equals 2 and y equals 8/7, which is just a little bit above 1. And now we're going to make sure that my function goes in the right direction around the vertical asymptotes. As x goes to -5 from the right, my function should go down to -infinity. From the left up to positive infinity. So we go back to our graph and make sure that from the right, f goes down to -infinity, and from the right, positive infinity. And so it seems pretty clear that my graph is now going to do this, and it's going to do this. If you are particularly worried, then we can check to see whether or not the function crosses its horizontal asymptote by taking a look at the reduced fraction. The reduced fraction is x plus 2 times x plus 2 over x plus 5. And we want to find out whether or not it actually ever crosses here. So we multiply both sides by x plus 5. Divide both sides by 2. Subtract x from both sides. And we get the lovely equation 2 equals 5, which has no solutions. And so if we were worried that the curve might cross the horizontal asymptote, then we can see that here it does not. Now, I've taken about 18 minutes to explain this. When we actually do it, it should take somewhere around 10 minutes. So what I'd like for you to do, if you struggled with this, is to, at this time, turn off the video and go back to the original function f of x equals 2x squared minus 8 over x squared plus 3x minus 10, and walk through the entire analysis process. And as you do, I want you to pay attention to the way in which you communicate. Make sure that you are communicating clearly. Make sure that you are avoiding common misstatements. And common misstatements would be things like setting something equal to 42 over 0. No, no, definitely no. And also not setting your limit equal to 0 over 0, which is definitely wrong. We want to avoid reasoning from 0 over 0 to therefore whole. That's not true. 0 over 0, the indeterminate form indicates a common factor which can be canceled. Let's see, what else would we like to avoid? I think that's kind of it. If you're thinking in terms of clear communication, you should be pretty okay. Ah, yes, one more thing to avoid. Please do not try to make your excluded values into something else, such as a 0 on the graph. Well, I hope this was helpful to you. If you need to, pause the video at this time and do the problem a second time. Doing the problem a second time will help you to think through this more carefully and clearly.